A flight data recorder, or black box, records every detail of an aircraft's operations, from engine speed to cabin pressure. After a crash, investigators extract the data to determine what went wrong. Black boxes are actually bright orange, so they'll stand out amid the wreckage. These black boxes are the deployable type, meaning they separate from the aircraft upon impact. This makes them easier for search and rescue crews to recover. To make the outer shell that houses the components, they use a two-part mold, first waxing it to ease extraction later on. Then they brush on an orange-tinted gel coat, a liquid that, after 4 hours, hardens into a durable waterproof finish. Over the hardened gel coat, they apply pieces of fiberglass cloth, saturating them with orange-tinted resin. They apply extra pieces in the corners for reinforcement. They continue until they've built up 3 layers of fiberglass. The rectangular box on this mold half casts a cavity in the shell, which will house the device's key components. They embed aluminum plates within the fiberglass to reinforce the area where screws will attach the cavity cover. A computer-guided milling machine contours a piece of foam that will fill the empty space inside the shell. This foam absorbs the force of impact, so the flight data recorder can survive a crash. They coat one side of the foam core with resin paste, then lay it into the mold. They fill voids with a temporary retaining block to prevent the foam core from collapsing inward during the vacuum process that comes next. They wrap the mold in felt to protect the surface, put it in a plastic bag, attach a hose, then start the suction. Over 4 hours, the vacuum slowly extracts the air, drawing the fiberglass tightly against the foam core without any wrinkles or puckers. It takes another 4 hours for the resin to completely cure. Then they remove the mold from the vacuum bag, coat the other side of the foam core with resin paste, and embed steel reinforcements. Besides absorbing the force of impact, the foam core makes the flight data recorder buoyant should the aircraft go down in a body of water. The device contains 2 antennas, the first of which gets pasted into a designated spot in the foam core. One antenna transmits a distress signal, the other a homing signal to help search and rescue crews locate the downed aircraft. Now they mate the 2 parts of the mold, carefully slotting the antenna that protrudes from one half through and out an opening in the other half. They bolt the mold closed and leave the paste to air cure overnight. The next day, they unbolt the mold and extract the shell, the 2 halves of which are now bonded, with the first antenna inside. Now they can install the other components, such as this memory module containing the circuit boards that record the flight data and cockpit audio. All components prior to installation undergo extensive testing to ensure they operate properly when subjected to vibration and extreme temperatures. The memory module goes into a fireproof box along with the transmitter that sends out the locating signal via the antennas, the second of which they now install into the component cavity at the top of the box. Then they install the battery that powers the transmitter for 150 hours. They connect the battery to the transmitter in the fireproof box, connect the transmitter to the antennas, then screw the cover to the aluminum plates embedded around the cavity's perimeter. The finished device undergoes a series of performance tests. This one, in a special echo-free chamber, verifies the signal the transmitter sends out via the antennas. The chamber's receiving antenna is connected to a computer which analyzes the signal's frequency and transmission pattern. Critical factors in recovering the box that provides vital clues for crash investigators. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitsmade.com.